Okay, so we're going to go over local maximum and minimums. Okay. Um, we went over absolute before, and that's when we were between intervals, but this time we'll have no specific intervals. We'll allow our x values to be all values of x. Okay. So we have our original function. What we're going to do is we're going to derive this function to get some critical points, just like we did when looking for increasing and decreasing functions. So the derivative of this function is negative 18x squared plus 36x. Okay. So we have the derivative of this function. We're going to set it equal to 0 so that we can find out any points where the tangent to the line would be 0, horizontal tangents. We will factor out negative 18x to give us x minus 2, which then leaves us with x value of 0 and an x value of positive 2. We set both of these equal to 0 to get these points. So these are the roots of the derivative. So if we were to graph the derivative, not what I wanted. If we were to graph the derivative, we know we have x-intercepts at these specific points of 0 and 2. Okay? We're going to use this information to figure out if our graph is increasing or decreasing at points also. So we'll set up a number line. And we know that our intervals are going to go from 0 to 2, from 2 to positive infinity, and from negative infinity to 0. So we're going to choose values between them and put them into our f prime x of negative 18x and x minus 2. So we'll take a value of negative 1, 1, and 3. Okay. So the very first one we plug in, negative 1. Negative 1 times negative 18 will give me a positive value, and negative 1 minus 2 will give me a negative value, so I have a negative value, which means we are decreasing at this point. Okay. Also, it's really important to know that we have a negative value because we have our roots here. So if I have a negative value, that means my graph is coming from below here. Okay, and as you can see, this is a quadratic. So we know we're coming from below at this point on the graph of the derivative. For f prime 1, same idea. Negative 18 times 1 will give us a negative value. And 1 minus 2 will also give us a negative value, so we will be positive. So this will be increasing at this point. This is positive, this is negative. That also means that between our two intercepts here, we have a positive value. So we know that is above the x-axis, which is very important for us. Okay? We know that the next root here, so as at some point our derivative must turn to come back down. And we're going to find increasing and decreasing, f prime 3. Positive 3 times negative 18 gives us a negative value, and 3 minus 2 gives us a positive value, so we have a negative number. So we know, again, this is decreasing. And for our derivative, the graph is below the x-axis. So we have some type of parabola here. Okay? Now, what we want to draw from this information is, first of all, we have gone from decreasing to increasing at 0. Okay? And anytime we go from decreasing to increasing, we have a local minimum. Okay? It's not an absolute minimum. For all we know, the graph might turn down again and go downwards forever. But we know we have a local minimum. And anytime we turn from increasing to decreasing, like we've done at 2, okay, that means we have a local maximum. So we know how to find a local minimum and a local maximum. There's another option, which we don't address in this specific question, where it goes from increasing at a point to increasing again. Okay? And that means there's no local maximum or minimum there. Okay? It's just turning and continuing up. It hits its tangent, which we'll see sometimes in cubic functions where it does this. Okay? But we're specifically looking at how to find local minimums and maximums. We're also going to use this information specifically from the graph. Now, we already know from the information we found that we're decreasing to increasing to decreasing. But let's say we didn't know that and all we had was our information of the derivative. Because the derivative at 0 is below the x-axis, that means we have negative values. And we know when the derivative is negative, so this is a sketch of f prime x. When the derivative is negative, we have a decreasing graph. So I'm going to draw our f at x in red, which means we're decreasing, and we'll put our two inflection points, one at 0 and one at 2. We know the graph is decreasing coming towards 0. We don't know exactly where it's coming from or what it's hitting. We know up to 0, we're decreasing. Then because the derivative is positive between 0 and 2, that means we have a positive value. And if a positive value with our derivative, that means we're increasing at that point. So the graph is coming back up again. And then from 2 on, we have negative values of the derivative. And we know that anytime we have a negative value of derivative, we are decreasing. So without doing that information, if we have a graph of the derivative, we can draw a rough sketch of our original by just looking at when the function is negative, positive, and negative, and specifically the two x-intercepts. The two x-intercepts will be our critical points, possibly local minimums and maximums.